Hi, I'm Mubarak, and this video will talk about the verification methodology manual. And if you have any doubts or clarification, you can mail me in thislove2esm@gmail.com. The verification methodology manual, or VMM in short, co-authored by the verification experts from ARM and the Synopsys, describes how to use the system verilog to develop a scalable and predictable and reusable verification environment. The VMM has become important factor in increasing the verification reuses and improved verification productivity and the timeliness. VMM consists coding guidelines and base classes. That base classes will provide you to implement different functions and different assertions and all. The VMM is focused on the coverage driven verification methodology. The VMM supports both the top-down and the bottom-up approaches. VMM follows layer test benches architecture and to take the full advantage of the automation. The VMM for system verilog test bench architecture comprises the 5 layers: the signal layer, command layer, and the functional layer, scenario, and finally the test layer. In the signal layer, we will write the interfaces, and into this layer connects actually the test benches and to the RTL by using the interfaces. And clocking blocks and mode ports are the different construct to use to synchronize the test bench and the RTL. The next one is command layer. The command layer will give the commands, or this layer contains a lower level drivers and monitors components, as well as the assertions. We can put assertion in this command layer. This layer provides a transaction level interfaces to the layer above the drives the physical pins and wire signals. The next one is functional layer. The functional layer will talk about the functionality, like this layer contains the higher level drivers and monitors components, as well as the self-checking structures like scoreboards and trackers or checkers. Here we will write the different components like monitor and the driver and the scoreboards or checkers for making test bench self-checking. Then next one is scenario layer. In the scenario layer, we'll have generators to produce the streams of sequence of transactions that are applied to the functional layer. The generators have a set of weights, constraints, or the scenario specified by the test layer. The randomness of constrained random testing is introduced within this layer. So here we will make some scenarios by using constraints and different sequences. Finally, the test layer can interact with all the layers like command, signal layer, and the functional layer and the scenario. The test layer located in this layer, the test cases are located here. The test layer can interact with all the layers. This layer allows to pass directed commands to the functional or command layers. So you can see that a block description of how the layer test bench architecture is architectured properly. So here we have different layers: test, scenario, functional layer, and the command signal layer. In the signal layer, we will have the interfaces to the DUT from the test benches, and the next one is command layer. In the command layer, we will have lower level monitors, checkers, drivers, and properties for assertions. So we can directly write the properties and assertion, and we put the coverages. Everything is possible in the command layer. And the next one is functional layer. In the functional layer, we will have some more advanced checkers, monitors, and drivers, some more higher level for making the self-checking test benches. And the scenario will generate the sequences, and it will have the generators, so it will make the higher level transaction. And finally, the top layer is test layer. We will have the test cases. We can provide the constraints and different directed stimulus from the test cases, and the coverage, the functional coverage, will have the interface to all the layers. So it will take pulses from all the layers and it will record into the database. So this is how a layer test bench works. Thank you for listening this video.